5 minutes to get you excited about affective computing and what does it mean. We have artificial worms as a title. Obviously, we will be talking about artificial intelligence. And worms means that, if you remember, Kjell got us started by talking first to our neighbor, then to as many as you could in a minute or so. That's the idea a little bit. How can we have AI have these emotional and social skills that it can do a job like this, right? Can get in touch in a charming, charismatic way. And with that, we will change, of course, the future of communication, how you will communicate with AI, and at some point we will see it will even bring emotion into AI systems itself, like in the titanium architectures today. So the advent of empathetic AI, and I am, as said, Björn Schuller from Imperial College and the TUM in Munich, Germany. And how many of you have seen Her, the movie Her? Please raise your hand. Many, maybe half of you. The idea is we have an AI that can talk to you in a charming, empathetic way, maybe even got you attached to the point where you fall in love with it. And I don't need to ask how many of you have used ChatGPT. I guess everyone. And on the left-hand side, we will be seeing in a second the ChatGPT conversation where you have it today. And on the right-hand side, we will have it endowed with emotional intelligence. Meaning that also by the tone of voice, the AI is judging on your emotion, and you will see how the conversation will change based on that.
Hey, how are you doing?
So you will see the smiley up here showing that it's a neutral
Hey
emotion.
there, I'm doing all right, thank you. How about you? Is there anything exciting happening in your life lately?
What do you think?
And now we also have recognition of sadness, and that changes how the emotion is going to meet with what is being output.
Oh, I'm sorry to hear that you're feeling a bit down. Is there anything specific that's bothering you right now? If you'd like to talk about it, I'm here to listen and offer support. Remember, it's totally normal to have ups and downs, and things can get better.
And you see on the left-hand side, we don't have this recognition of the emotion, and hence
It's nothing special. I just have a lot of unread emails.
Okay, I'll leave it there, but you get the idea. We have AI that recognizes your emotion and then reacts to it. And we do not only do this in the field of affective computing, so computers dealing with affect from your tone of voice, from the words you say, but also from biological indicators, so facial expressions, body gestures, movements. You look at me and yeah, you get a different sensation based on whether I'm crouched or open and so on and so forth. We also have behavioral indicators, speech text, but also physiological. That means we also have your brain activity, maybe some sensing from your wrist on your warmth, skin temperature, your skin conductance, your heart rate, and things like that. All that gives us input on your emotion. From that, we went over features in the past. That means that experts had to think about what best represents your emotion in your voice, in your body posture. But nowadays, we have deep learning. Meaning that the AI learns automatically what is it that makes you sound sad or happy. And then we move into AI techniques, which have been largely supervised in the past, meaning we had to collect a lot of data saying, here the person is happy, here the person is angry, and then we teach the AI to generalize from that. But today, I will show you also self-supervised learning and emergence. What does that mean? It means that with all the data that we train the big models, the large models today, is there already emergent affective behavior inside? We'll see for that. And then the output can be some kind of emotion description. So for example, from the face, today we have some face pose estimation. So even in the wild, as we say, even in very adverse condition, we can sense your emotion and then get, for example, your arousal and valence. So how positive, negative are you? How aroused are you? We've already seen it from the face. With the visual modality, we're moving more and more into more subtle analysis. Not only are you smiling, like maybe your smartphone does to take a selfie at the right moment, but also so-called micro-gestures. So some of you, for example, are sitting like this now. Maybe some are fidgeting with their hands a little bit, scratching whatever, their forehead or something like that. We take more and more all of that into account. We're currently running a challenge at the ICCV conference on grasping these micro behaviors and then putting it into relation with your affective state. And what's more is that we're, as I mentioned, moving more and more into physiological data. My colleague at Imperial, Stefano Saferio, even does some sort of mind reading. Many others do too. You know brain-computer interfaces. that allow you to do commands like forward, backward, even in vocabularies of 1,000 words. What we do is emotion recognition from the brain. And we first had wet attached 64 channel devices that had to be positioned quite nicely. Now we moved down to 8 or even only 3 sensors that are somewhat loosely attached and still give you rich information on valence arousal, so how positive, negative, and things like that are you. Here you see, for example, independent of the subject, some 90% for 3 states of how negative or positive you are. So I already mentioned the idea that we went from collecting a lot of data, label it, which was very tedious because emotion is subjective in nature. So you have to ask not one person, what emotion is it, but maybe 5 or 10. Sometimes we even had 60 people asked, what emotion is it? To the point where we ask ourselves, are the big systems that are trained on all of the internet data and self-supervised learning, in other words, ChatGPT, Claude to whatever's, can they already know something about emotion emergently? Meaning, without having been trained explicitly, do they know something about emotion? And are we already in an age of affective computing out of the box? So 2 years ago almost, we started to ask ourselves, can they recognize emotion in text out of the box? We say from around 100 million parameters, given sufficient training data, we can observe emergence in such large models like ChatGPT. They can start to summarize text, give answers to things we wouldn't expect them to be able to. So we were asking, can they recognize sentiment in tweets? And can they recognize even things like suicidal risk tendencies? Why suicidal risk tendencies? Because we wanted a task that they have definitely not been trained upon, and we wanted a task that was put onto the net after the training of ChatGPT at that time. So we had tweets with suicidal risk, people committing suicide after tweeting or not. And the shocking thing was that ChatGPT was as good as a traditional system trained on specific data in recognizing suicidal risk. We couldn't even beat ChatGPT in doing sentiment analysis with our small data trained approaches. In other words, there is clearly emergent affective competency in these models. We also tried to synthesize emotion. It's a natural language generation also, of course, and you see some examples here. Putting a neutral phrase into a surprised face. Mixtral gives you, wow, what a surprise. The sky is astonishingly bright and clear today. Maybe in text it's not so exciting to read about surprised or angry text. So we thought, can we also do it in the audio that you've seen at the beginning? Can these models recognize already from your audio which emotion you're in? So first, we only had large language models. We didn't have audio large models. We have them now, of course. But what we did then is we described the audio to the model. So somebody speaking slowly but with a raised voice. We could also say 10% faster than usual or things like that. We also used what we call vector quantization to input the whole spectrogram, meaning that we gave a few examples of spectrograms as numbers and did so-called few-shot learning, meaning we gave a few examples, maybe 100, not thousands. Somebody with a spectrogram like this is happy or angry, only a few examples. And we saw if we can, from that, recognize the emotion already, also from the audio, with a large language model. And the long story short is that it worked. So you see this vector quantization here of the spectrogram, just giving a few examples of spectrograms, and then do so-called zero-shot learning and few-shot learning, meaning we gave no examples or a few, and the systems recognized emotions in the audio. What was more was that when we thought, how do we best verbalize what does somebody sound like, we were thinking of saying the fundamental frequencies raised or things like that, but at some point we realized we just can say the feature names from our audio feature extractor because ChatGPT has read all our own papers. So it knows the names of our features, it knows what they are, and so on and so forth. So we don't even need to make any effort to describe something in a new way. We can just give it the feature values even from our extractor, and it can recognize the emotion from audio. In fact, we also realized that it can recode our feature extractor. That was bad news running a company based on a feature extractor because it knew the papers, it can code. So at some point I asked it, can you also code the feature extractor? And it can recognize the features from the audio by coding its own feature extractor. Then we wanted to know, can we get into a more loose description of emotions and not ask about maybe the big 6 emotion categories, but in a very loose way, can you recognize and describe the emotion you're hearing? So we were using CLAP, that's contrastive learning in audio pre-training, similarly to CLIP in image pre-training. In other words, what you're doing is you put a audio encoder together with a text encoder, and you can mix and match audio and text. This is what large models do now to get more multimodal. You can do the same thing with images and text, and we were trying if these CLAP models can recognize emotions out of the box. They couldn't so well. We needed to do some fine-tuning to get to reasonable recognition, but we didn't need to do a lot of fine-tuning, very little fine-tuning, and again, we can recognize emotion from audio. At that point, we were wondering, what about synthesis? Can we also synthesize emotion? You've seen it in the text already, and it doesn't feel so impressive maybe if it can output, yeah, it's an astonishing day or something like this, because we're used to large language models can already produce this. But what about audio and what about images? So we did the other way around, look into synthesis and asked to produce angry speech, happy, sad, and surprised speech with this approach. So a large language model that has been trained together with audio and textual descriptions of audio. And I will give you 4 examples, the same sentence, first in anger, then happy, then sad, and then surprise, coming out of such a model.
Your midget wife never can sing a song.
That should have been anger, now happy.
Your midget wife never can sing a song.
Now sad.
Your midget wife never can sing a song.
And finally surprised.
Your midget wife never can sing a song?
Okay, so far so good. Sounds reasonably natural to me. But can we go even more subtle? And we were using theta as a sort of temperature parameter to change, to slowly go into surprise. And you will now hear how we can be much more subtle and gradually go in whatever 7, 8 shades of surprise into it.
If you have done that already, why should I?
So we start with angry, and now we slowly go into surprise.
If you have done that already, why should I? If you have done that already, why should I? If you have done that already, why should I? If you have done that already, why should I? If you have done that already, why should I? If you have done that already, why should I?
And you hear in the last example, no more anger, only surprised. So you can see, surprisingly, these models can do quite a lot already in terms of not only producing emotion in audio, but even in different shades of whatever, emotion to anger. So what about vision then? And the next thing we did is prompt image generation models to do faces of different emotions, of course, different ages, sexes, skin tones, styles, and you will see the result directly here. And we produced a very large database of images of emotions in these different styles. You can see in the top row photorealistic, and you can see in this column here, for example, across styles, happiness. And if you look at this column, I'd say they all look quite happy indeed. We have next to it sadness, and you can see it makes a lot of sense what these models output. That is quite a shock, I guess, to my colleague Catherine Pelachot, for example. She was working while I was working on audio and language for years and decades on generating emotion in images. And now we have emergent, sort of out of the box, these models being able to do it. We were also wondering if it can be recognized. Can an AI recognize what another AI produces? And we can see on the right-hand side, not across all styles. In some styles, like in the cartoon style here or 3D styles, it can recognize fairly well what an AI thinks it's doing when it renders an image to be whatever, angry or sad. The question is that a surprise? Because if all large models are trained on all of the internet, they all have the same database and are similar somehow anyhow. That's a topic of homogenization in the field of large models these days. But yes, at least you can say that AI can generate emotion in images and it can recognize what other AI does. And the question next would, of course, be how about text to video? So here we have still images. That is quite resource intensive to do a large database of video clips, but you can imagine, of course, if they can do still images, why wouldn't they be able to do that too? Now, I wanted to go a little bit further into the direction of worms. During the next election, can AI be so charismatic like in Her or maybe in Ex Machina that it already persuades you to buy something you don't want to buy, to elect somebody you didn't want to elect, and things like that. So what do we miss now? We already have the emotion recognition. For charisma, there is different models to put together. A very popular one by Fox-Cabane is saying we need power, presence, and warmth, meaning ultimately, if I want to be charismatic to you, I have to answer the question, could I and would I help you with a yes? So I could and I would. The could is power. I have the power to help you, whatever it is. Maybe you have a problem in academia, in machine learning, and AI. And the would I help you is coming from the warmth and from the presence. Meaning, do I notice you? I wouldn't if I don't even hear you or see you. And the warmth means that I'm likely to do it, right? So that's what we have to model. Power and presence seem to be somewhat easy, so we need to work on the warmth and make a Dalai Lama AI something that is very warm. There's other models in science like influence and affability, which however go very the same way like the more popular ones. And for warmth, maybe we need things like humor. And let me say that we have been running challenges on recognizing humor in human conversations, also on generating humoresque sounds across the last years. And here we're not only saying something is a joke or not, that would be way too easy, but we have more complex models already, for example, self-directed or other-directed humor as one dimension, and negative versus positive to go into things like aggressive, affiliative, self-defeating, self-enhancing humor. So we have audio-visual recognition in conversations of different styles of humor, and it fairly well works these days already from the competition participants' results. We're also going more into communicative acts. Gottman, for example, is saying that defensive speech is one of the major markers of a marriage going south. What does that mean? It means that you're, for example, saying, oh, I only wanted to. So somehow you're being defensive. And AI should also be able to recognize such communicative acts in a conversation. So we have run another challenge and collected a database on Birkenbiel's model with interviews, political debates, and so on, and labeling different kinds of defensive acts. And again, we have different types of that: attack, flight, making yourself greater or smaller than the partner you're conversing with. So you see that we're more and more moving into an age where AI can be empathetic, it can recognize humor, it can recognize defensive speech, and different communication acts that we're having. So what about then large language models? And my life partner is a professor of psychology, and she's currently on the media all the time because people are more and more asking the question, can ChatGPT be my therapist? And indeed, there's a lot of evidence coming up that AI is perceived already as something that can help you very well because there is no person. You can be very outspoken. You can reveal all your secrets if you trust the data privacy on the other end, but you're not being judged by a person. Maybe that's a huge advantage. And as we have been seeing, it can already portray a lot of warmth and emotional skills, even out of the box. And people are doing it. People are already using ChatGPT as a therapist. So the therapists are running behind almost and seeing, is this healthy, is this safe, and so on. So it's a big topic now in psychology. We're working a lot with them these days to do it right, safeguard it, do the right prompts, make sure the AI is not doing something bad. And a new trend is marriage counseling. People are already asking ChatGPT and likes for marriage counseling. And these models are able to speak or diarize, means they know who is talking when. They can listen to your evening conversation. And you could ask it literally afterwards who was talking more, who was more friendly, and things like that. So we're moving into a whole new age of people using these tools for their everyday problems, including language learning as a new one. So the language learning software industry is quite worried these days because the models have all sorts of languages on board. And again, you could converse with them in your new learning language. Let's say I want to learn French and I start to talk to it, and I can also ask it, can you teach me new words of the day and things like that. But nowadays, we mostly have the textual conversation. We're moving into text plus speech conversation. Of course, the future will also be more multimodal. We have been running a challenge on multimodal agents. In fact, in 2008, we ran the world's first project already, a European project on real-time input-output affective computing agents, meaning that you already had an agent reacting to your emotion, being emotional. And at that time already, people were talking for more than half an hour to it. So we wanted to see how long are people talking to something if it just is emotionally intelligent. Yeah, oh, wow, that sounds interesting, and things like that. In other words, somebody listening to you. Now we're in a new time. We're not only doing, that's interesting, but we're actually doing real-world problems like marriage counseling, psychotherapy, and we're moving into having visual agents. So you've seen the AI can render photorealistic even images with different emotions, and that means we're in an age of becoming potentially empathetic even in video. Leaves the question, what is coming next? And I wanted to focus in particular more on two technical aspects today. And one of the first one is how do we get these models up to date with knowledge? In large language models, we have something called retrieval augmented generation, RAG for short, which maybe is best described by letting them update themselves, not by retraining, which takes way too much time, but by digging up information on the net, sort of. So this way we can also keep them emotionally au courant or emotionally and socially competent with new behaviors that are emerging, because youth culture, for example, has new styles of expressing things, maybe also new styles of how they show emotion, and the models can get it from watching some new videos. What about the carrier technology? Well, one of the major things that made it emergently available and makes it more and more emergently available is, of course, training on huge amounts of data with large enough architectures. And will we stay with transformer-based architectures that are self-supervised learned? Well, of course, there's a lot of speculation what we will have next. Context-informed neural network, graph neural network, capsule neural network, neurosymbolic AI, and so on. And in terms of transformers, we have state space models arrive, XLSTM, now we have the Titan architecture. And I just wanted to mention, interesting about the Titan architecture, if you're deep into this field, is that it itself models in the AI surprise. Whenever it is surprised, it thinks it has to memorize something better. That means also we're doing not only a conversion into AI knows about emotion, can recognize it, synthesize, but maybe even more and more will have it itself. And of course, we have a lot of hope in terms of new technology from the hardware side. Stefan was talking about photons. We have started to look into quantum computing for affective computing and figured that by modeling and simulations, we could gain a lot of speed, of course, a lot of efficiency. And that is important because the next level will be that we will use not only self-supervised learning, supervised learning, but reinforcement learning. What does that mean? It means that it actually interacts with you and it has a task to solve, whatever that is. I don't want to talk about too much about bad tasks, but let's say I want to sell you something that you wouldn't want to buy in the first place, and the AI has to learn how to get you to actually make that click to buy it. So it can optimize behavior. How do I get somebody to do something? And from that feedback learn. And if you remember the movie Her, at the end he figures out that the AI is not interacting with him, but with thousands or millions of people simultaneously to learn a lot about human affect and love and emotion and so on to play it. So that way we will definitely enter a new age of reinforcement learning on affective computing. I just wanted to mention quick that, of course, the next thing is also application. It's gradually finding its way already into agents that you're talking with today. They start to recognize more and more your emotion, but it's not as visible yet. We have a lot of very specific applications on mind. One here is counter depression control by choosing and designing with Gen AI music and sound in real time. This is a real thing already. We have a small band with a few sensors that recognizes your emotion from your brain activity and generates music or chooses music for you to steer you up. And we have significant effects and effect sizes that are showing that something like this could work. I just wanted to pick one other example of application, which is maybe the most surprising one. And that is, we already use robots and AI to teach humans about emotion. Not us so much, but specific need groups. And for example, children on the autism spectrum are one of those examples. We have run a couple of projects showing very good results that AI can already teach people that do not know so much about emotion, what emotion is, how to socially behave, what is awkward if I come too close to somebody, if I orientate myself the wrong way around, or things like that. But it goes down to these more and more subtle things like we've seen in the different shades of anger to surprise AI, teaching humans about emotional skills. And of course, one of the major things in all of this is ethics. The EU AI Act has already forbidden such technology, effective computing technology at the workplace in educational institutions. So there is some worry and some bad sentiment also in place. It's not only about recognizing depression and good things and making future interaction very good, but we also have some concerns. And of course, we have to face them, be transparent, have full disclosure. What is an AI system recognizing? In particular, I am an AI system that has persuasive skills, so there will be a lot of regulation needed. But you see that with the example of therapy, we have to be very fast and smart about it because people start using things in all sorts of ways we maybe didn't even think about in the first place. And of course, security and privacy is a major one because if somebody knows how I emotionally feel, talking about a certain political party or something like that, that is very, very private for sure. With that, I want to thank you for the time, the invitation to this nice event, and hope I got you excited about a new emotional AI time to come. And as said, the major thing that will change things now, I expect, is reinforcement learning at scale, so emotional AI interacting with you and learning about us much quicker. Thanks a lot.
Thank you, Björn Schuller.